Welcome to Strength of Materials in 6. Today's video is going to be on transformation of stress. This is one of the new modules that have been brought in. So let's have a look at that. So first we will investigate the stresses on a 2D element. Usually when we refer to an element in this particular module, we will draw it as a square. But in reality, it is actually an element that has got the shape of a cube, okay? Because in real life, of course, shapes have volume, okay? But for the purpose of analysis, we simplify our study and present that 3D cubic element as just a 2D element, okay? And so it is a square, a 2D element that's got the shape of a square, but in reality, and in the back of your head, I want you to view it as a cube, okay? It's really important. The only reason we refer to it as a 2D stress element is because it's much easier to do the analysis when assuming that, when simplifying the element to just a 2D shape or a plane, okay? So it's really important to bear that in mind. And so when you have a 2D stress element, we will usually, in fact, in this module, it will always be presented to you as a square, and the stresses are going to be drawn on that element. And so first, it's important to remind you that the horizontal axis is the x-axis, and the vertical axis is, of course, the y-axis. Okay, so we will refer to those two lines as the xx line and the yy line. And the reason they are very important is because the normal stresses act along those lines. So for instance, the normal stress acting along the xx line will be referred to with a subscript x. And as you can see, this normal stress here is tensile, and therefore it is positive, okay? In this case, when we have stresses that are tensile, we refer to those stresses as positive stresses, okay? And if we had stresses that were compressive, those stresses, of course, will be negative. But in this case, what we have there is positive stresses because these stresses are tensile. And so these are normal stresses acting along the xx line, but we also can have normal stresses acting along the yy line. And as you can see, we've used the subscript y to refer to those stresses, just to say that they act along the yy line. And they could be tensile or compressive. And again, I repeat, when we're dealing with stresses in this particular module, stresses that are tensile will be considered to be positive, and the ones that are compressive will be considered to be negative, okay? Very important. And so this blue line that you see here will represent the positive x face, okay? Because if your origin is where the two lines meet, the x axis is positive to the right, okay? So this face that we have here, we will refer to it as the positive x face. Again, remember I told you that for the sake of simplification, we look at this stress element in 2D, but in reality, it is a 3D cube, okay? And so this line that you have here will therefore represent a face. And in this case, it's the positive x face simply because it is on the side of the positive x direction, okay? Therefore, the one on the other side, of course, will be the negative x face. And then you can imagine what the face here and here are going to be. Of course, the one on the positive y direction will be the positive y face, and the one on the negative y direction will be, of course, the negative y face, okay? Very important. Now, when you have a 2D stress element, generally, it is not only loaded with normal stresses, but you may also have shear stresses acting on the element, okay? And so this is what we are going to look at right now. But before we do that, I need to explain something to you very quickly. So when we have shear stress acting on an element, okay, the shear stress will have two subscripts. You can see with the normal stress we only have one subscript. It's either X or Y, okay? But with the shear stress you will have two subscripts, okay? One will be X, the other will be Y, or maybe it may start with Y and then X after. So it's really important to understand how we label these, and this is what I am going to explain to you, okay? So the first subscript is the one that will refer to the face where the shear stress is, okay? That's what will be the first subscript, okay? So for instance, if the shear stress is here, okay, the face where the shear stress is the X face, okay? It's the negative X face, but really, when you're looking for the subscript, what you will write here, if the shear stress was here, it will be X, okay? It will be X, because this is an X face, although it is the negative X face, but it is an X face, okay? So subscript 1 is the face where the shear stress is, okay? And if you want to know what will be the sign of subscript 1, then you will look at whether the face is positive or negative. So for instance here, the sign of the subscript will be negative, okay? The face is an X face, and the sign of the subscript, if the shear stress was here, will be a negative sign, because this face is a negative face, okay? And subscript 2 is referring to the axis the shear stress is parallel to. Again, if my shear stress is here, you will see that it is parallel to the y-axis. So in this case, the second subscript that I will have for my shear stress will be y, because my shear stress here is parallel to the y-axis. And the sign of my shear stress will depend on the axis sign convention. So for instance, if my shear stress was pointing up, because it is parallel to the y-axis is positive pointing up, therefore the sign of subscript 2 will also be positive, because it is pointing up as and that is also the positive direction for the y-axis, okay? If my shear stress was here and pointing down, the second subscript, subscript 2, will of course be y, because y is the axis that the shear stress is parallel to. However, its sign will be negative, because if my shear stress is pointing down, therefore it is pointing in the negative direction of the y-axis. So the sign of subscript 2 will be negative. But now, a word of caution is that when we deal with the sign of these subscripts, we do not write them on the subscript, okay? You do not write minus x or minus y. You do not write plus x or minus y, or maybe minus x and plus y, okay? You don't write the signs on the subscript, but rather what you do, you multiply the signs together, okay? Positive and positive gives you positive, positive negative gives you negative, negative positive gives you negative, and negative negative gives you positive. So you will multiply the signs of the subscript, and then you will take what you get as a sign and you will place it in front of your symbol for the shear stress. That's basically what is done. I am going to illustrate that with an example very soon, just to make that very clear. And so let's say we have a line like this, and this is the line that represents a shear stress, okay? And so because it represents a shear stress, we will already write the Greek letter tau, okay, for shear stress. And now we need to label this shear stress and give it subscripts, okay? And as I explained earlier, we have two subscripts that we need to give it, okay? The first one is the face where the shear stress is. If you look at this shear stress here, the face where it is an X face, okay? So the first subscript, therefore, it's going to be X, okay? And the second subscript is the axis the shear stress is parallel to, okay? The axis the shear stress is parallel to in this case is that axis, okay? And this axis is Y, okay? So therefore my second subscript will be Y. But it's not over yet. Now we need to establish what is the sign of that particular shear stress. And as I said to you, for the first subscript, the sign is positive if it is on a positive phase and negative if it is on a negative phase. In this case, the shear stress is on a positive X phase. So for subscript X, the sign is positive, okay? Now let us look at subscript Y, which is the second subscript. Subscript Y is positive in the direction of the axis sign convention. In this case, the axis this shear stress is parallel to is the y-axis. Y is positive upwards, okay? And this shear stress is pointing up. Therefore, subscript Y here is positive. So we have a positive subscript for X and a positive subscript for Y. Therefore, the whole shear stress here with that direction is positive, okay? Very important. Let us look at another example. Now, let us look at the shear stress on this negative Y phase. Again, you begin by writing the letter tau for the shear stress. And the first subscript here is the phase where the shear stress is. In this case, this shear stress is on a Y phase, a negative Y phase, but it's a Y phase. So therefore, the first subscript is Y. And then the second subscript is the axis the shear stress is parallel to. If you look at this shear stress, it's parallel to the x-axis. So therefore, the second subscript is X. But that's not the end of it. Now we need to establish the sign of that particular shear stress based on the sign of the subscripts. So the first subscript here, Y, is negative, okay, because it is on a negative Y phase. So Y is negative. This subscript Y has a negative sign. Okay, now subscript X, its sign will depend on the sign of the x-axis. Because the shear stress is pointing in the negative x direction, okay, so subscript X is also negative. And so subscript Y is negative, X is negative, 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 that gives you a positive. So the direction of this shear stress on this negative Y phase will still give you a positive shear stress. And you can go on and play with it, and you could look at these shear stresses on these other faces and try and see whether they are positive or negative shear stresses. And when you use the approach that I showed you, you will find that the shear stress on this face pointing in this direction will give you a positive shear stress, and that one also will give you a positive shear stress. So this leads me to the next point I am going to make. When you're dealing with a 2D stress element, it's either you will have an arrangement of the shear stress in such a way that it is positive on all faces, or you will have an arrangement of the shear stress in such a way that it is negative on all faces, okay? You cannot have a mixture of positive shear stresses and negative shear stresses on the same stress element. It's either the shear stress is negative on all faces or it is positive on all faces. And the other important observation to make is that the shear stress magnitude is the same on all faces. Okay, so very important to remember. And for that reason, therefore, when we have shear stresses like we had in this figure, which are represented again here, okay, instead of labeling each of these arrows and writing shear stresses on each of these arrows, we can just label it like that, okay? Because as I said to you, the magnitude of the shear stress is the same on all faces. So if you just take the magnitude of this one and you write it here, we will understand immediately that on all these faces the shear stress has this magnitude. And this direction, as you saw it in this picture here, and which are replicated again here, okay, this direction for the shear stress, that is the positive direction for the shear stress, okay? And of course, an element may be loaded also with normal stresses, which is what I show here in blue. Okay, this is just a random example of how normal stresses could be loaded on a 2D stress element. And in this case, put negative stresses in the y on the y along the y axis. Okay, and the reason I say these stresses are negative is because they are compressive. Okay, but the ones on the x-axis are actually positive normal stresses because they are tensile. Okay, so really important to remember. So when you see shear stresses that have arrows as you see in this figure and in that figure here, okay, these arrows, when they are pointed in these directions, okay, these represent a positive shear stress. And so we do not label each of the arrows and write the magnitude of the shear stress on each of the arrows, because a 2D stress element always has the same magnitude of shear stress on all its faces. We will just label it at the corner like that. Okay, so this is the direction of positive shear stress. Okay, very important to remember. And what you see here, that will be the direction for a negative shear stress. Okay, so on this particular stress element, the shear stress is negative on all the faces. And again, we do not need to label the shear stress on all of these faces, because the magnitude is the same. We can just write at the corner there